Video problem number 32, mass percent in empirical formulas. These particular problems deal mainly with mass percent. So let's see what we got here. How many grams of carbon are in 5 grams of CO2? So what we want to do is we want to take the percent composition, or in this case the percent of carbon that's in CO2, and multiply it by 5.00 grams, okay? Because you have 5 grams of this whole compound, and we know that carbon only makes up a certain percentage of that compound. So what we're going to do is we're going to take the mass of carbon over the molar mass of carbon dioxide. Now, technically, the percentage would be times 100, but we don't want to get the percentage, we want to know the percentage. So we don't necessarily have to multiply by 100 in this case. So we can take this value and we can multiply by 5 grams, and that's going to be the grams of just carbon. All right. So let's see, get out your periodic table. Carbon is 12.01. All right, and then that's going to be over carbon dioxide. Let me show you the molar mass of carbon dioxide. It's about 44, but let me show it to you. Carbon is 12.01. We've got the 2 oxygens. That's 32, so that's going to be 44.01. That's how many grams are in 1 mole. Okay, so I'm going to take 12.01 over 44.01 grams. All right, and then that's grams, and I'm going to multiply that by 5 grams. So let's see what we get. Order of operations important here. Whoa. Sorry, I'm trying to fix my calculator. Okay, we got it. So 12.01 divided by 44.01 and multiplied by 5. So we get a value of 1.36. We're going to 3 sig figs here, so 1.36 grams of carbon. That means if I were to carry out some sort of a chemical reaction where I'm able to isolate just the carbon, I would get 1.36 grams of carbon out of this substance. Okay? Alright, so look at the next one. Determine the number of grams of just oxygen in 2.5 times 10 to the negative second moles of barium nitrate. Now there's a couple different ways we could actually do this problem. Let me show you if we use percent composition first. We can take, so this is the first way that uses percent composition by mass. Right. So we're going to take first, let's take our 2.50 times 10 to the negative second moles of barium nitrate and convert that to grams. We're going to convert that to grams, so grams going to go on top, moles on bottom. Grams over moles, moles over grams, that's molar mass, and it's molar mass of whatever's in front of it, which in this case is barium nitrate. So let me get the molar mass of barium nitrate here. Alright, so we've got a barium, get out your periodic table. What do you do to a dead guy? You bury him. That's 137.33. How many nitrogens? We've got 2 nitrogens. Each nitrogen weighs 14.01, so that's 28.02. Then we've got 6 oxygens, so 6 times 16 is 96. So let's add that up, 96 plus 28.02 plus 137.33. So the molar mass of barium nitrate would be 261.35 grams per mole. Alright, so we got 261.35 grams per 1 mole. So now I can get my grams. I'm going to take 2.5 e to the negative c second multiplied by that molar mass there, and I get a value of 6.53 grams of barium nitrate. Now, of that barium nitrate then, I can use my percent composition by mass to figure out how much oxygen. So I'm going to take 96 over, here's the molar mass, 261.35 grams. And this right here, this is the percent of oxygen by mass. Okay? And so I'm going to get some value here. So let's see, multiply that by 96 divided by 261.35, and I get a value of 2.4. So I get 2.4 grams of oxygen. So that's one way to do it. Another way that you can do it is you can do percent composition by moles. So percent of moles, and I'll show you that right now. Okay, so then we start out with moles. 2.5 times 10 to the negative second moles of barium nitrate. And then what I can do is I can say that there are 6 moles of oxygen for every 1 mole of barium nitrate, which is the percent by moles. Excuse me, sorry, I hope I didn't explode your eardrums there. So I'm going to take 2.5 times 10 to the negative second, and I'm going to multiply by 6, and that's going to give me 0.15 moles of oxygen. And then if I want to get the mass, I'm going to take 0.15 moles of oxygen, and I'm just going to convert it to grams. So grams, moles, grams over moles, moles over grams, talking about molar mass, so that's 16 grams per 1 mole. So that's times 16, and I get 2.4 grams of oxygen. Okay, so there are a couple different ways to do the same type of problem.